Hey guys, how's it going? Welcome to day 24. Today's a very important video for you with some important PVA concepts. Um, we need to know the relationships and things from day 23's video, but generally the questions are asked in these types of ways on the AP exam. So again, these kind of four things that we're going to look at today are very, very, very important, and knowing how to solve them and what to do. So again, make sure you take good notes. I would suggest starring and boxing this page because we're going to be using this information quite a bit, and the sooner that you can commit this to memory, the better. Okay, let's take a look at our first concept that you might be asked about that you need to know the meaning of. Okay, one of the types of questions that you might be asked is at what time is an object at rest? I forgot the T. Well, what time is an object at rest? You might get asked this question, and it's very important that you know conceptually what's happening. Okay? If an object is at rest, okay, we need to know that that means that the object is not moving. What a lot of people think of then is like, oh, like it's at zero, right? But my question that I'll always ask you is, what is at zero? Is its position zero? Is its velocity zero? Or is its acceleration zero? Okay, what we need to understand is an object at rest, it doesn't matter about its position or its acceleration. What matters is its velocity. Okay, it's all about velocity. So anytime they ask you about what time is an object at rest, we need to understand that this means v of t equals 0. An object is at rest when it has 0 velocity. Now notice, I'm not plugging in 0 for t here. I'm setting my velocity equation equal to 0. And then I'm going to solve for t because that's what I want to know. For example, just a small example here. Let's say a position function is this. Okay, so let's say an object's position is modeled by this function, x of t equals 2t squared minus 8t plus 1. The question is, at what time is this object at rest? So the first thing we need to know is if they're asking about what time the object is at rest, that's going to be when our velocity is 0. The problem is I didn't give you a velocity equation, I gave you a position equation. So the first thing we need to do is get a velocity equation for this object, whatever it is. Okay, well, how do I go from a position time equation to a velocity time equation? Well, that's simple. That's from yesterday's video. I just do the derivative. So what I know is x prime of t is going to equal v of t, which equals 4t minus 8. Okay. So I know that my object has a velocity equation that can be modeled by 4t minus 8. Okay, because that's the derivative of position. Because velocity is the rate of change of position, and we know that in calculus we can get instantaneous rates of changes by doing derivatives. So now what I need to do, I'm not done yet. That's my velocity equation. Now I need to set my velocity equation equal to 0. And now I just need to solve for t. So at t equals 2, my object has a velocity of 0. My object is at rest. Okay? Now, if I had just given you the velocity equation, then you would have just set that equal to 0. You don't always have to do a derivative. Okay? What you always have to do is get to v of t, whichever way you can, and set v of t equal to 0. Okay? So that's a very important concept. At what time is an object at rest? Okay? It's at rest whenever our velocity is equal to 0. All right. Important concept number 2. All right, let me read. Excuse me, our second concept here is on what intervals is an object moving left or moving right. Sometimes they'll ask you, over what time period is this object going left, or over what time period is it going right? Okay. Well, again, think back to day 23, yesterday's video. How do we determine the direction that an object is traveling? Well, we determine that by looking at the sign of velocity. Remember yesterday when we had a negative velocity? I just said, that means the object is moving left at that speed. Okay? If we had a positive velocity, our object was moving right. So if an object is moving left, what we have to understand is that it's going to, that object is going to have a negative velocity. So an object will move left whenever we have a negative velocity, whenever v of t is less than 0. Okay? An object is going to move right then whenever v of t is greater than 0. Okay. Another thing to keep in mind here is this is if it's moving on the x-axis. If we're moving on the y-axis, you can replace the word left with down and the word right with up. Sometimes, too, we use cardinal directions for this. Okay, usually east is positive, west is negative. Okay, but we'll see some examples with things like that. If they give you a different context, just try and figure out which one is the positive direction, which one is the negative direction. Okay, but usually they're left and right. Left is always negative, right is always positive. Okay. For example, let's say this. So let's say a velocity equation is measured, is given by the quantity t minus 4 times t minus 8. So I want to determine here when our velocity is negative and over what intervals is our velocity negative, and over what intervals is our velocity positive. Okay, I'm going to do this by doing what's called a sign test. So here's the question. The question is, what intervals is the object moving right? Now, we're going to do these sign tests quite a bit in the next couple months here. So it's really important to understand the concept here. So again, I want to know when is the object going right. So what I need to understand is an object moves right when the velocity is positive. That's the concept that you need to know immediately, like you know your own name. Okay? Now what we need to do now is figure out, okay, how am I going to determine, without a graphing calculator, where this function v of t is positive? Okay? Or if the question was about moving left, I'd want to, how can I determine where this function is negative? Well, in order to figure this out, to figure out where something, where of an equation is positive or negative, we first need to figure out where is that equation equal to 0. So my first concept here is find when v of t equals 0. We need to know where v of t is equal to 0 so we can tell where it's going to be positive or negative. So set v of t equal to 0. Now this is already factored for us, right? So I can figure out where v of t equals 0 by setting t minus 4 and t minus 8. Since that's already factored, I can set both parts of the equation equal to 0 and solve each one. So what I've determined is that the velocity is 0 at t equals 4 and t equals 8. That's not the answer to the question, okay? But those are the times when the object is at rest. Okay, so what I want to do now is create a sign chart. And I want to look at the domain here. The domain is t is greater than or equal to 0. And I want to do a v of t sign test. Okay, so I'm doing a velocity sign test. What I want to do is I want to plot the two zeros I have. So I want to plot 4, and I want to plot 8. Okay? I know the velocity is 0 at those places, so we can put a little velocity of 0 right above it. Now, those are the only two zeros. So those are the only places that my velocity could change signs. What I need to do now, right? So if you think between 0 and 4, I can choose any number I want between 0 and 4 and plug it into my velocity equation. And if I get a positive number, that means every single time between 0 and 4, the velocity is positive. If I get a negative number, then every number between 0 and 4 is negative, has a negative velocity. I only need to test one because I can't switch from positive to negative, okay, without going through 0, as long as I have a continuous function, which this thing is. So here's what I like to do. I like to choose an easy number. And again, I'm plugging in not to figure out what the number is. I'm plugging in to figure out what the sign is. And I'm going to record that sign on my sign chart. So let's think of an easy number to plug into our equation between 0 and 4. I can include 0, but I do not want to include 4. So I'm going to pick the number 0, okay? Or another easy one might be 1. Right, you can use 3, but try and make it as easy as you can because this will likely be on the no calculator part. So I'm going to plug in 0, and I'm going to plug it into my v of t equation. I'll write it again down here. Now, I know most people are really interested in figuring out the number, okay, but I'm not concerned about the number, I'm concerned about the sign. So I'm going to pick 0 and plug it in for t. Well, that's going to make that first term 0 minus 4. 0 minus 4, is that a positive number or a negative number? Well, 0 minus 4 is negative because it's negative 4. But I don't care that it's negative 4, I care that it's negative. I put a little negative right above it. Plugging in 0 to the second term, t minus 8 gives me 0 minus 8. That gives me another negative number. And what I know is a negative times a negative is always a positive. So that tells me that at 0, at t equals 0, my velocity is positive. That means my velocity has to be positive for every number between 0 and 4, because there were no other zeros in there between 0 and 4. So what I do is I write a plus right here. I know from 0 to 4, from t equals 0 to t equals 4, my velocity is positive that entire time. Now I need to check another number. I don't need to check any other numbers between 0 and 4 because I know that whole region is plus, has a plus velocity. Now I'm going to choose a number between 4 and 8. I'm going to choose the number 5. All right, now I'm choosing this for t and plugging it into my equation. When I plug it in, I'm going to get 5 minus 4. 5 minus 4 is now a positive number. So I'm going to change that minus to a plus. Okay. And when I plug it into the second term there, I'm going to have 5 minus 8. That's a negative number. So right now I have a plus times a minus. A positive times a negative is always negative. So I know my velocity is negative at t equals 5. But not only is it negative at t equals 5, it's negative for every t value between 4 and 8. So I'm going to put a little negative up here. Now, since my domain was just t greater than or equal to 0, right? I don't have any right boundary on my next region, but I know my left boundary is 8. So I just need to pick a number bigger than 8. I like to pick 10. My favorite numbers are 0, 1, 5, and 10 because they're easy to plug in to test. So I'm going to test 10. 10 minus 4 I know is a positive number. 10 minus 8 I know is now a positive number. So I'm going to switch that minus to a plus. And what I know is that a positive times a positive is always positive. So I know from 8 all the way out to infinity, okay, my velocity is always 100% going to be positive. Okay, that's how we do an accurate sign test. We just need to check, we find the zeros first, and then we check the regions between the zeros. Okay. So now I have to answer my final question, which is on what intervals is the object moving right? Well, I can see it's moving right. Well, I need to know it's moving right whenever my velocity is positive. Looking at my sign test here, it's really easy to see that velocity is positive between 0 and 4, union 8 to infinity. This is another time when they will most likely ask you to justify your response. Okay, so going back to the question here, we're going to say justify. Our justification is that definition that we know an object moves right whenever the velocity is positive. Okay, but here's a place where students oftentimes don't get specific and can lose the justification point. Okay, not only the most common thing is mistake that people make is they say because that's where it's positive. Don't say that because they don't know what it is. They don't know if you're talking about position time function, velocity time, acceleration time, right? So a justification here, because that is where v of t is greater than 0. Okay? Make sure you are specific there. You need to say v of t is greater than 0, not say that's where it is greater than 0. Okay? So be specific. Okay. The third thing that we're going to look at. The third type of question that they like to ask is, at what time or times does an object change directions? Well, this idea of direction goes back to 2 and goes back to yesterday's video. The direction of an object is determined by the velocity sign. Right? If velocity is positive, we know the object's going right. If velocity is negative, we know the object's going left. To change directions, right, we have to switch signs on velocity. So an object changes directions, right? This happens when v of t switches signs. Okay. Now, sometimes people think of this as, okay, an object is going to change signs at what number? Well, something is going to change signs going through 0, right, with a continuous function. So a lot of times students inappropriately assign this as, oh, v of t equals 0. It's more than that, okay? That's how we identify candidates, but we have to do a sign test to make sure we actually change signs. For example, we could have a function that approaches 0 from the positive range, touches 0, and then goes back on the positive side. That would not change, v of t would not have changed signs. Therefore, the object would not have changed directions. Okay? So, I like to think of it as identifying candidates. Okay, so we identify candidates for times when an object changes directions by setting our velocity equal to 0. But we need to do a sign test just like we did in problem 2. So let's just look at that example from problem 2, right, with v of t equals the quantity t minus 4 times the quantity t minus 8, right? We got zeros of t equals 4 and t equals 8. To determine for sure that those are places where the object actually changes directions, we have to look at our sign chart to determine if the velocity actually switched signs or not. Okay, when we take a look at that, okay, let's just scroll up here and take a look at that. We can see here at t equals 4 and at t equals 8, the velocity does change signs. So those would be examples of places where an object changed direction. Notice at t equals 4, the velocity switches from positive to negative. At t equals 8, the velocity switches from negative to positive. Both of those places are times when this object would have changed directions. Okay? Good. Fourth thing, last thing. Uh-oh. Last thing I want to look at is speed increasing and speed decreasing. Okay. Again, anytime you see this word speed, you need to be very careful. Okay. Sometimes people think, oh, this just is the acceleration positive or negative. Okay, but it's more than that. Okay. Speed is going to increase. I'll show you a demonstration in class. I can't do it on this video. I'll show you a demonstration in class on Monday about this. But speed is increasing whenever we need to always check both velocity and acceleration. Okay? So speed is going to be increasing anytime velocity and acceleration have the same sign. So if velocity is positive and acceleration is positive at a specific time, then the speed is increasing. If velocity is negative and acceleration is negative, then the speed is going to be increasing as well. Okay? So it could be plus plus, it could be minus minus. Either way, if velocity and acceleration have the same sign at a specific time, then we know that the speed is increasing. Speed will be decreasing then when v of t and a of t have opposite signs. So if my velocity is positive, but my acceleration was negative, I know my speed is decreasing or I'm slowing down. If v of t is negative and a of t is positive, then those two have opposite signs. Therefore, the speed is decreasing as well. Okay, let me show you an example of what I mean by that. So here's an example. I'm giving you a position function, okay? And here's my question. Let's say at t equals 5, is the object speeding up or slowing down? Justify. You will definitely be asked to justify this as well. Okay? So what's important to know here is you need to check both v of 5 and a of 5. You need to check both of them to determine whether or not this object is speeding up or slowing down. Again, speeding up is the same as speed increasing. Slowing down is the same as speed decreasing. So the first thing I need to realize here is that I was given a position function x of t. So I need to get my velocity equation and I need to get my acceleration equation. I'm going to do that by doing derivatives. Here's what I know. I know v of t must be equal to 3t squared minus 15t plus 18. And right away, just so I don't forget, I'm also going to get my acceleration equation over here. A of t, I'm just going to do another derivative, and I'm going to get 6t minus 15. Okay. So now I just have to figure out v of 5 and a of 5. Okay. Okay, so 5 squared here is 25. 25 times 3 is 75. Minus 15 times 5 is also 75. Okay, I'm going to have 75 minus 75, which is 0, plus 18, which equals 18. So what I need to understand here is that v of 5 is greater than 0. Okay? A of 5 I'm going to calculate over here. A of 5 then would be 30 minus 15, which is 15. And again, I need to understand that a of 5 is greater than 0. So what I see here is that v of 5 and a of 5 are the same sign. They're both positive. So I know that anytime velocity and acceleration are the same sign, I know that the object is speeding up. I can say the object is speeding up at t equals 5. Be specific, tell the grader what time. My justification is because, don't say they have the same signs, that's not being specific. We want to say because v of 5 and a of 5 are the same sign. And that is a good specific justification to answer this question. All right, that's it for today. Oof, kind of a long one, but you got a lot of days to watch it. So I'll see you guys on Monday. 2 chains. Bye.